Let's imagine what could be your thought if the person sitting next to you were talking about the Big Bang Theory. You might think, yeah, not just a few thousand years back, but billions of years ago, there was only empty space. There was no planets, no galaxies, not even Earth as we know it today. Over time, light began to form, temperature started to drop, subatomic formed atoms, and slowly matter came together. Life found its way, starting with simple organisms like amoeba, evolving through monkeys, and eventually leading to us humans. And this is exactly what scientists are trying to prove. What truly happened in those first moments after the universe began, though the concept of known as the Big Bang Theory. What if I told you what you think might not be completely true nor completely false? To help you understand, imagine calculating the distance from Earth to Sun using an equation. The result might be close, but there could be still a slight difference from the actual distance. Just like that, when it comes to the origin of the universe, there's no direct evidence to show exactly what happened before it all began. So, scientists rely on experiments, postulates, and a few assumptions to build a theory like the Big Bang theory. So, let's understand in this video who were the scientists behind the Big Bang theory and what exactly did they contribute to help us understand what happened after the origin of the universe. Let's get started. So, before we dive into the scientists who contribute to the Big Bang theory, let's first understand the three powerful assumptions that gave them the foundation to explore and support this groundbreaking idea. Assumption 1: Universality of physics law. The assumptions like the law of physics, like gravity, light, and motion, are the same everywhere in the universe and have stayed constant through time. That means what works here on Earth also works in the farthest galaxy. These assumptions let scientists apply what we know locally to understand the whole cosmos. Assumption 2: The cosmological principle. This principle says the universe is homogeneous and isotropic, meaning it looks the same in all directions and from every location if you zoom out far enough. Assumption 3: Matter behaves like a perfect fluid. In the early universe, matter was so hot and dense that it behaved like a perfect fluid, smooth, with no friction, and with pressure directly linked to its density. This helps explain how the universe expanded and formed structures like stars and galaxies. Now that we understand the assumptions, let's meet the brilliant minds who built the Big Bang theory. Georges Lemaitre, a Belgian priest, physicist, and astronomer, also known as the father of Big Bang theory. In 1927, he published a paper that could quietly start a scientific revolution. He became the first person to propose that the recession of galaxies, the way galaxies seem to be moving away from us, was not a random. It was evidence that the entire universe is expanding. Even more amazingly, he connected this observation to Albert Einstein's field equation in general relativity. He started to solve equations under the assumptions that the universe is homogeneous and isotropic. And what did he find? That an expanding universe was not just possible, it was the natural outcome of Einstein's own equations. While others thought that the universe was static and unchangeably, he dared to think bigger. He proposed that all matter and energy were once packed into a single, extremely dense point. He called it as a primeval atom, now what we call as a Big Bang theory. At the time, his idea was radical. Even Einstein at first dismissed it. But Lemaitre stayed true to his math and observation. Years later, after Edwin Hubble confirmed that galaxies were indeed moving away from each other, Einstein finally acknowledged Lemaitre's insight, calling it the most beautiful and satisfactory explanation of cosmic expansion. Edwin Hubble, an American astronomer based at Wilson Observatory in California, in the 1920s, using one of the most powerful telescopes of his time, Hubble made a game-changing discovery. He observed that distant galaxies were not standing still, they were moving away from us. The farther away a galaxy was, the faster it seems to be moving. This confirmed what George Lemaitre had proposed mathematically just a few years earlier. And here's something fascinating. After Einstein saw Hubble's result, he realized that the universe is not static, and he publicly admitted that introducing the cosmological constant to keep the universe from expanding was his greatest mistake. Hubble didn't just prove the universe was expanding. Once we thought the Milky Way was the entire universe, but his telescope told a different story that our galaxy is only one among billions and each galaxy is as vast as our Milky Way galaxy. In 1965, two radio engineers named as Arno Penzias and Robert Wilson were trying to fix a problem with their antenna. They kept hearing a faint, persistent noise no matter where they pointed their instrument. It wasn't from the Earth or the galaxy. It was coming from every direction in space. What they had accidentally found was the cosmic microwave background, the ancient leftover radiation from the Big Bang itself. This was smoking gun, the strongest evidence that the universe began in a hot, dense state and has been cooling ever since. For their accidental historic discovery, Penzias and Wilson were awarded the Nobel Prize in Physics, and their find became one of the most important pillars of the Big Bang theory. During the 1970s, two brilliant minds named as Stephen Hawking and Roger Penrose took Einstein equation to their logical extreme. Using advanced mathematics, they showed if general relativity is correct, then the universe must have started from a singularity, means a point of infinite density and zero size. Their work gave theoretical strength to the idea that space and time had a true beginning, just as the Big Bang theory suggests. Hawking and Penrose didn't just support the Big Bang theory with math. They pushed our understanding of time, black holes, and the boundaries of the universe itself. These brilliant scientists played a vital role in shaping what we now know as the Big Bang theory. Their discoveries changed how we see the universe and our place in it. If you enjoyed this journey through science and space, don't forget to like the video and to subscribe to the channel.